Hello and good morning, Doctor and dear examiner. So my name is Jabar Kananta and my metric number A23CR40011 and my supervisor is Dr. Nur Aziza Saadon. I'm from software engineering department. So for the for my proposed system is StunCore, which is a mobile-based stunting screening system using decision tree algorithm. For the PS1 evaluation and progress presentation, first, why I choose the clinical urgency for childhood stunting because the national stunting rate currently is around 19.8% by survey, which is 4.48 million children affected in Indonesia. So for this for my stakeholder now, they operate based manually, which is they still use the paper records, fragmented history, and it will consume time, which is will consume around 30%, and it will affect to delay intervention for the children. So the core vulnerability is a missed early detection due to disconnected manual tracking. So for the evaluating the current digital landscape, I think the analysis existing tool reveal a critical gap in predictive explainable clinical screening. So which is when I come for the I compare with the other system. My system is including with the automated z-score calculation, which is faced with the current client, and the capability for parent-facing mobile interface, predictive machine learning classification, and integrate health worker dashboard, which is for the two predictive machine learning classification and integrated health worker dashboard is the what I propose for the to the client. So for the engineering stack, for the for clinical environment, the tools that I use is a Flutter and Vue.js, which is in the client layer. It will a cross-platform and the consistency and data-rich reactive dashboard. And for backend, I use Express.js and offer Node.js, which is APA orchestration. It will queue and RESTful request handling and GWT authentication. For database, I use a MongoDB, which is a data percentage. It will have a seamless NoSQL storage for longitudinal health record. And for the machine learning, I just use the Python, and it will the model of machine that I use is C5.0 algorithm, which is more interpretable and rule-based machine learning for auditable decision. And this is the actor, which is a parent, health worker, and system administrator. So for the parent, it will access mobile app, and health worker, it can access web dashboard, and the system administrator, it can access web dashboard as well. So simple for the parent, it will be simple data entry, offline capable validation, color recoded screening result, accessible guidance. And however, is a rapid record review, severity following, follow-up status management. And then for the administrators, is a metadata control, robust audit log, system analytics, and role-based access enforcement. And the functional blueprint is we have a 22 validated use case. For the first module is user access, and then for the second, child records, and third, assessment, four, history and reports, five is dashboard, and six, administration. So with the three distinct user role and six functional models and 22 validated use case, the conceptual blueprint is established. And now for the architecture solution, when I did the progress to. Here, plan for PSM2, which is it will, because now I use a plan driven, which is the waterfall methodology. And for the first phase that I have done is the requirement analysis, which is in the PSM1. It's already complete. This is stakeholder consultation, its analysis, and its RS documentation. And the phase 2 is system design, which is for the status now it's already complete as well, which is 4-tier architecture and OSQL schemes, UI wireframes, and SDD documentation. So for the next step in the PSM2, phase 3, we will I will do the implementation, which is will cover Core API, C5.0 pattern integration, and Flutter or Vue.js coding. And the last phase is a testing and deployment. This is it will cover 45 case study STD execution UIT at hospital, and then this is the system composition for tier architecture. So first we have a client layer, API layer, domain layer, and data layer. And next, the algorithm intelligence, which I use now for the model machine learning, which is the C5.0 decision pipeline. Why I use C5.0? Because it's interpretable decision rule chosen over black box model to ensure health worker can audit clinic rational. So it will, so when input the age, gender, age, weight, the CS 5.0 model will runtime for in the interface, and then it will make a decision which is normal, at risk, or standard for the score. And this is the data persistence for the MongoDB document architecture. You have a user profile collection, child profile collection, chronicle, and we'll have two chronicle array and this document structure, which is will go to the measurement record and classification result. So this is the interface prototyping tailored user realities. It will a parent view, which is really, and then health worker view. And then for the verification strategy, so because this 100% traceability, and I have the 45 distant test case explicitly mapped to 22 SRS use case. It will cover functional, validation, and security and performance. So now for the PS1, for my honest review, reading for the system implementation that I did in the PS1 now, from the progress one until the final, I learned that I found a difficulty to decide, which is because it's basic stakeholder, a real stakeholder, and need to find the best model, but have a minimum latency. So the model that the hard thing is to find the machine learning model. And at the end and final, when I found it, so I just use the recommended one, which is C4.0, that is most the newest one, and mostly is relate to the project now. And then for the foundation that I set for the architecture, database system, and interface frame, I still didn't think yet, but I just like go through with what I did in the PSM1. So and the later if there is any improvement or update anything, so I will just go on to the PSM2, which is in the for the coding one. So my vision for the standard, it will replace fragmented paper records with explainable and machine learning driven platform. So it will transform early detection at my current client at the hospital. And that's all for the presentation, and thank you.